The James Webb Space Telescope has revolutionized astronomy in 2024, delivering discoveries that challenge our deepest understanding of the universe. From stunning images of distant galaxies to data that defy conventional theories, the telescope has unearthed anomalies in the early universe that suggest something extraordinary might have happened even before the Big Bang. The telescope's observations of ancient light and distant galaxies have revealed anomalies that don't align with existing theories of cosmic evolution. Strange patterns in the early universe's structure, unexpected galaxy formations, and puzzling hints of pre-Big Bang conditions suggest that the universe's history may be far more complex than previously imagined. These discoveries are not merely filling in the gaps of our knowledge, they are reshaping our understanding of the universe's origins. Theoretical models, from inflationary theory to the concept of a singular starting point, are being re-examined. Scientists are now exploring possibilities such as a cyclical universe, hidden dimensions, or interactions with other universes in a multiverse framework. In this video, we will take a closer look at these groundbreaking discoveries and explore how they challenge everything we thought we knew. Well, before diving into these astonishing revelations, it's essential to first understand the basics. What current theories tell us about the size, age, and origins of the universe? By starting here, we'll gain a foundation to appreciate just how monumental Webb telescope's contributions have been in reshaping our understanding of the cosmos. Let's embark on this journey to uncover how the James Webb Space Telescope is rewriting the story of the universe's past, present, and future.
If you're in any doubt about how significant these new images are, I wish you could be in this room, because around me are the scientists, the astrophysicists, the cosmologists who really understand how they've changed our view of the universe.
This kind of data in a fraction of the time that we were before. So I think a lot of the records that we have in the current day universe, those are going to be broken really soon.
And they say, well, what's new? What did you find out that we didn't know before? And of course, the big answers are the first galaxies grew differently than we expected, and we don't know why their old predictions were wrong.
It says that the universe has an ancestor, which is another universe.
Consider this. When the Webb telescope looks as far into space as possible, it will only see about 46.5 billion light-years away. This is the radius of our visible universe, which we call the Hubble radius, or Hubble sphere. But we know that our universe is expanding. However, this expansion is not like objects moving outward into empty space. It is the expansion of space itself. This idea can feel counterintuitive because there is no central point from which the universe is expanding. Instead, scientists understand that the expansion of space occurs everywhere at once, uniformly stretching the distances between objects. If we think about this expansion, it will seem as if everything in the universe is moving away from each other. But here a question must be arising in your mind that if everything in the universe is moving away from each other, then why do we observe galaxies colliding, and why is the Andromeda galaxy moving toward the Milky Way instead of away? Well, the answer lies in gravity. When the gravitational force between two objects is strong enough, it can overcome the expansion of space. And scientists have also observed that space is not only expanding, but it is accelerating, which means that distant galaxies are moving away from us at a faster rate than nearby galaxies. As we know that the farther a galaxy is, the faster it is moving away from us. So when we look at distant galaxies, we will see that in a specific region in space, some galaxies are moving away from us at the speed of light. Scientists have called this region the Hubble sphere. And the galaxies beyond that region are moving away from us at a speed even faster than the speed of light. So common sense would say that we will never be able to see the light coming from those galaxies, because the light coming from these galaxies is moving away from us at a speed faster than the speed of light. But surprisingly, this is not true. We can still see the galaxies that exist beyond the Hubble sphere because the Hubble sphere is expanding due to the accelerating expansion of space. And as this region expands, it brings more and more distant galaxies into our view that are moving away from us faster than the speed of light. But there is a limit to how far we can see into the universe, and this boundary of the universe is called the observable universe. It is about 93 billion light-years across in diameter. There are many more galaxies and stars beyond the observable universe. We don't know how big the entire universe is. Most scientists believe that the entire universe may be infinite in size. What's even more fascinating is that the observable boundary of the universe depends on where you are. An alien civilization in a different galaxy would see a completely different version of the observable universe because they'd have their own unique perspective. Now, there is one more mystery that makes our universe even more strange. When we look at distant parts of the universe, we're actually looking back in time. We don't see those regions of space as they are right now, but rather as they were in the past. This happens because light takes time to travel through space. For example, if we look at something 1 light year away, we're seeing it as it was 1 year ago. The farther we look, the further back in time we see. So far, scientists have observed more than 13 billion light years into the early universe using powerful telescopes. And with the help of these observations, scientists have created a standard model of our universe, which shows what the universe looked like at different time periods in the past. Like, if you look more than 13 billion light years away, then you will see the Dark Ages, which means that at this time, the whole universe was covered with dark clouds of hydrogen gas. According to the standard cosmological model, if we could look all the way to the edge of our observable universe about 13.8 billion light years away, we would see the very first moment of our universe, the Big Bang. Now, according to our standard cosmological model, which says that about 14 billion years ago, the entire observable universe and everything beyond it that we can't see would have compressed into a tiny infinite point we call the singularity. Actually, no. That would be true if the universe is finite. But if the universe is infinite and it kind of looks like it is, then it was always infinite. So the Big Bang would have happened literally everywhere. This means that the first galaxies did not form in any particular region of space. They formed everywhere in the universe, even beyond the observable universe that we cannot see. It seems as if matter came into existence everywhere in the universe at a particular time. And the cosmic microwave background radiation that we see everywhere in the universe is the first light of matter coming from every direction in the universe. So this is what our theories tell us about the size of the universe and how it came into existence. But the new discoveries of the James Webb Telescope are challenging all these theories and forcing us to rethink our understanding of the universe. Let's talk about all these amazing discoveries one by one. Recently, scientists discovered many ancient supermassive black holes, which poses a major challenge for astrophysicists. One of these black holes is so strange that our theories completely fail to explain it. And scientists are claiming that this black hole may have formed before the Big Bang. In a paper published in Nature Astronomy, scientists reported the discovery of an ancient supermassive black hole, one that existed very early in life of the universe. While some enthusiasts have claimed that the observation of these gigantic black holes has disproved the theory of the Big Bang, our standard cosmological model, which is based entirely on observations and our physics theories, predicts that in the early universe, black holes were formed from the remains of massive stars. When these stars ran out of nuclear fuel, gravity caused their cores to collapse, creating incredibly dense objects called black holes. However, observations from the Webb telescope have unveiled a more diverse cosmic group. It has discovered a number of black holes that do not fit neatly into the expected story of stellar collapse. Some are surprisingly massive, challenging traditional views of stellar evolution. Astronomers were surprised when they found that the mass of this strange black hole at the center of the ancient galaxy was about the same as the total mass of the stars in that same galaxy. To put this into perspective, the supermassive black hole at the center of the Milky Way is only about 0.1% the mass of the entire galaxy. Given that this ancient supermassive black hole formed so quickly after the universe began, it cannot have been created by the collapse of stars and merging of stellar mass black holes. Instead, another mechanism is required. Sophisticated simulations have shown that early in the history of the universe, it is possible for giant clouds of gas to have collapsed directly into very large black holes, ones with masses about 100,000 times that of the Sun. But the James Webb Telescope found other such ancient supermassive black holes at the very edge of our observable universe, which indicates that the direct collapse of dust clouds in the early universe would not be enough to explain this mystery. But wait, scientists at the Kavli Institute for Physics and Mathematics of the Universe have made a surprising finding that indicates that these black holes may have formed in a baby universe. One exciting possibility is that primordial black holes could form from the baby universes created during inflation, a period of rapid expansion that is believed to be responsible for seeding the structures we observe today, such as galaxies and clusters of galaxies. During inflation, baby universes can branch off of our universe. A small baby or daughter universe would eventually collapse, but the large amount of energy released in the small volume causes a black hole to form. In simple words, it says that before the Big Bang, baby universes collided with our universe, and these collisions created primordial black holes in the early universe. Here is a proof that supports this claim. Approximately 10 years, Nobel laureate Dr. Roger Penrose has been touting extremely dubious claims that the universe displays evidence of a variety of features that are consistent with our universe colliding with and being bruised by whatever occurred prior to the Big Bang. This theory completely explains how supermassive black holes formed in the early universe. Primordial black holes could be responsible for some of the observed gravitational wave signals and seed supermassive black holes found in the center of early galaxies discovered by the James Webb Telescope. In addition to this, the team hypothesized that primordial black holes could also play a role in the synthesis of heavy elements. This theory could explain the unexpected heavy elements that observed in Webb Telescope's early galaxies. So these new Webb discoveries suggest that primordial black holes were created by the collision of baby universes with our own. This primordial black hole theories perfectly explain the unexpected discoveries of the James Webb Telescope. So, is our standard cosmological model wrong after all? When scientists looked at the new observational data, they were stunned. No one expected that we would see something like this. Scientists noticed that many early galaxies beyond the edge of the early universe suddenly appeared in this data. One of these galaxies has a redshift of about 17, which is impossible according to our current models. Well, recent observations have shown that this galaxy was actually an imposter among these distant galaxies. Spectroscopy data revealed that this galaxy actually had a redshift value of 5. The dust cloud situated between the Webb telescope and this galaxy caused the galaxy to appear extremely far away, almost like a distant celestial object. Peter Van Dokkum, an astronomer at Yale University not involved in the latest research, said that the Webb telescope has observed possible galaxies even closer to the Big Bang, but they have yet to be confirmed. However, some of the candidate galaxies, if confirmed, would have existed when the universe was less than 200 million years old. Scientists say what this data is showing is actually a big problem for our standard cosmological model. This huge population of galaxies near the Big Bang brings more questions for us to solve. Recent observations have uncovered something unexpected in the early universe, challenging scientists globally and suggesting that what the Webb telescope found may be a major problem for our standard model. In an unprecedented discovery, astronomers have spotted a mysterious structure located deep in the early universe. The discovery has baffled scientists as it challenges our understanding of cosmic origins. Right now, astronomers don't know what this strange structure is, and what is especially surprising is that it has been found to be much older than the Big Bang. In a newly published research paper, scientists have put forward 3 potential explanations for this peculiar structure. They've carefully analyzed each possibility and concluded that the first 2 are improbable, while the third appears to be the most plausible. However, they caution that if the third explanation holds true, it could herald the most significant shift in the field of astronomy. In the paper, scientists revealed that this object could be a galaxy that would have observational properties similar to the little red dots recently discovered by the James Webb telescope. But scientists found that this red galaxy is situated at a redshift of Z equals to 15, indicating that it existed just 100 million years after the Big Bang. If this third explanation is true, it would be the oldest and most distant known galaxy ever observed. Well, the discovery of these tiny red dot galaxies has already been a big headache for scientists because these galaxies are much more massive and bright than our models predict. And now we've found another object even further away that may completely break the standard cosmological model. This revelation poses a significant challenge to our current understanding of the universe. As per conventional cosmological norms, galaxies aren't supposed to form so early. Let's consider this. One of the pillars of cosmology is that the spatial distribution of matter in the universe is uniformly isotropic. It means that everything looks the same in all directions if you look over large enough distances. This is obvious, since the forces are expected to act equally throughout the universe on a large scale, and should therefore produce no observable inequalities in the large scale, structuring over the course of evolution of the matter field that was initially laid down by the Big Bang. Wherever you look, you will find the same density of matter, the same temperature, and the universe is expanding equally everywhere. For more than a century, scientists have been developing various cosmological models with the assumption that our universe is uniform in all directions. The Big Bang model, which is the best theory to understand the universe, is also based on this assumption. The cosmic microwave background radiation also shows that the universe is the same everywhere. But a recent study published February 6th in the Astrophysical Journal Letters suggests that there may be something seriously wrong with this assumption. Recently, astronomers have confirmed that the expansion rate of our universe is not the same everywhere in the universe. In this paper, they revealed that depending on where we look, the universe is expanding at different rates. Well, this is a big problem now because if the universe is expanding at different rates in different places, then it will create a major problem for astronomers. This new study also suggests that we may be completely wrong about the current estimated age and nature of our universe. David Gross, a Nobel Prize-winning astronomer, said, "We wouldn't call it a tension or problem, but rather a crisis." New images of James Webb telescope confirm that the previous measurements are correct, and the universe is expanding differently in different places. This disparity in the value of the expansion rate of the universe suggests that perhaps the universe is not the same everywhere. Well, if this is true, then our standard cosmological model would fall apart. Since we cannot estimate the age and size of our universe with different values of expansion rate. And the most important question that will arise is, what is the reason for the universe expanding differently at different places? One intriguing reason could be that dark energy, the mysterious force that seems to be driving acceleration of the expansion of the universe, is itself not uniform. In other words, dark energy is stronger in some parts of the universe than others, causing different expansion rates. Scientists claim that if the universe is not homogeneous and isotropic, then it would mean that the physical laws as we understand them are impossible to comprehend. Just over the cosmological horizon, the force of gravity might act in reverse. The speed of light might be slower than walking speed, and unicorns could be real. Well, this new discovery of the Webb telescope has caused a great debate among astronomers. This is because the non-uniform expansion of the universe challenges the cosmological principle, and it is one of the foundations of astronomy. The James Webb Telescope again discovered an ultra-high red-shifted galaxy which shattered all our theories. Scientists just discovered F200 DB045 is a candidate high redshift galaxy, with an estimated redshift of approximately ZE equals sign 20.4, corresponding to 168 million years after the Big Bang. If confirmed, it would be one of the earliest and most distant known galaxies observed. Well, this galaxy is still one of the most distant candidates and will have to undergo many tests to get confirmation. But if confirmed, the standard model would need to be revised again to obtain a better estimated age of the universe. The galaxy the telescope found at Z equals to 14.32, called Jade's GS-Z14, has several hundred million solar masses. This raises the question, how can nature make such a bright, massive, and large galaxy in less than 300 million years? Also, astronomers have detected carbon in a galaxy observed just 350 years after the Big Bang, in observations that raise the possibility that the conditions for life were present almost from the dawn of time. The presence of oxygen so early in the life of this galaxy is a surprise and suggests that multiple generations of very massive stars had already lived their lives before we observed the galaxy. All of these observations together tell us that Jade's GS-Z14 is not like the types of galaxies that have been predicted by theoretical models and computer simulations to exist in the very early universe. With all these data, scientists are now claiming that the James Webb Telescope will soon observe galaxies from when the universe was very young, at a redshift of 20. This means looking back in time to when the universe was just a few hundred million years old. However, they are concerned that if the telescope finds even more distant galaxies, this could challenge our understanding of how galaxies form. According to our standard cosmological model, there is a limit of our universe beyond which we cannot see anything it is called dark age. Following the Big Bang, the universe entered a period known as the Dark Ages. During this time, the universe was filled with neutral hydrogen gas, and there were no stars or galaxies to emit light, making it opaque and dark. So far, everything we know about the universe beyond the Dark Ages is just theory. No one really knows what lies beyond it. Surprisingly, new images from the James Webb Telescope have revealed galaxies that existed even before what we call the Dark Ages of the universe. This discovery is baffling scientists, as it's unclear how these galaxies could have formed so early. What's even more puzzling is that these ancient galaxies look nothing like the galaxies we see from the early universe. These findings raise a profound question. Could we be looking at an entirely different universe? Why do we keep finding giant and mature galaxies as we look deeper into the universe? If our physics is correct, we should see small and young galaxies as we look deeper into the early universe, and there should be no galaxies or stars after a certain distance. But as the Webb telescope looked into the early universe and beyond, finding more and more massive galaxies, it seemed we were looking at a different universe with different laws of physics. Here's a galaxy called Sears 2112 as seen by the Webb telescope a few million years after the Big Bang. Scientists say that the size of this galaxy is almost similar to our galaxy. The existence of such galaxies, like our Milky Way just few million years after the Big Bang, poses a major problem for our standard cosmological model. Astronomers thought barred spiral galaxies such as the Milky Way didn't appear until the universe reached at least half of its current age, because it was believed that it took several billion years of galactic evolution before the massive collections of stars within galaxies could form central bars. Astronomers previously thought this galactic structure marks the end of a galaxy's formative years, so it was expected to be seen only in old galaxies that may have reached full maturity, perhaps those that existed halfway through the evolution of the universe. Indeed, the Hubble Space Telescope's past observations of galaxy morphologies have shown the early universe hosted very few barred galaxies. However, the new findings, gleaned from data by the James Webb Space Telescope, conclude it may not be necessarily true that barred spirals must have roamed the universe for so long. The discovery of spiral galaxy, Sears 2112, reveals galaxies that resemble our own already existed 11.7 billion years ago, when the universe had just 15% of its life. Over billions of years, galaxies underwent remarkable transformations through processes like mergers, collisions, and the formation of new stars. This evolution, observed through telescopes, shows how galaxies have changed in size, shape, and composition. The intriguing aspect is that this evolution isn't just random, it's a continuous learning process. But the discovery of Sears 2112 has suggested that this evolution only took about 1 billion years or less. Well, the existence of these impossible oldest galaxy candidates in this Milky Way-like galaxy, a few billion years after the Big Bang, is a serious challenge to our theories. Are we missing something in our galaxy evolution models, or are we completely wrong about the early universe and its origins? If you have watched this video completely, then do share your thoughts in the comments. Thank you.
You discover something new, it doesn't create a problem so much as it creates excitement, a new understanding of the universe. We delight in this. It's not like we're all sitting back with our legs up on the table saying, basking in the knowledge of the universe that we have command over. No, we are always at the drawing board. And to people say, scientists will have to go back to the drawing board, we're always there. If you're an active research scientist, that's where you live. And you are befuddled daily. Plus, of course, the universe brims with mysteries.